Hi, I'm Christina Epp, and I'm a reservoir engineer with IHS. Today I'm going to be presenting assessing opportunities using IHS data and IHS DeclinePlus. So the purpose of this presentation is to show a workflow for asset valuation and demonstrate the interoperability of IHS AccuMap, IHS Harmony, and Entero Mosaic. So IHS AccuMap and IHS Harmony are all part of the IHS family, whereas Entero Mosaic is a third-party software that we will be using in this workflow. So each of these programs have their own strengths, and they're definitely complementary to each other. And if you combine all of them together, you come up with a seamless workflow for asset valuation. So what is asset valuation? Well, asset valuation is an integral part of the larger decision-making process. Whether you're doing acquisitions and divestitures, mergers and partnerships, asset diversification, if you're looking at well spacing or doing communities of best practice, asset valuation is a helpful tool in all of these situations. And especially if we look at today's dynamic economic environment, the conditions are changing quickly, and adapting to this new environment of low oil and gas prices and reduced budgets. Asset valuation, being able to do that in a quick and efficient manner is definitely going to be helpful. So in this new economic environment, for some this may only require optimization of their existing assets, but for others, perhaps faced with unexpected or unplanned costs or decreased revenue, this may mean selling off some assets. And then for others, those able to hold on to cash or raise cash, there will be opportunity to actually acquire some assets. So again, being able to do a quick and efficient asset valuation is going to help everybody adapt to this new and evolving environment. So what I'm going to go through today is I'm going to look at a test case of drilling 50 gas wells in the Montney in the first half of 2016. Now we're going to be using the evolving completion technology, and the point of this is to determine, will this project be economically viable? So as we're going through this, we need to address some of the uncertainties, things like the cost or the technology that we're using, and we also need to understand what price forecasts we'll be using. So the general workflow that we're going to be going through is we're going to start off in IHS AccuMap. We're going to identify a sample of wells and filter those wells down. We'll take that information into IHS Harmony and do some further filtering, generating a type well and a rate forecast, and then that information we can take into Entero Mosaic and determine the economic viability of the project. So to get a little deeper into this process, the data flow is we're going to start off in IHS AccuMap and use the IHS Information Hub data. We'll do some querying in there and output a well list. We can import that well list into IHS Harmony, where we'll then use type wells, decline analysis, and numerical modeling to create a rate forecast. We can take that rate forecast into Entero Mosaic, and along with other inputs such as drilling schedules, project costs, and price forecasts, we can use the project economic evaluation tool to output the cash flow report with economic indicators. So I'm going to go into the software now, so into AccuMap. And AccuMap incorporates the data from the IHS Information Hub. So it has information on things such as the location, the rate data, the on-stream year, along with a lot of other information. So what I've done is I've gone through and I found all the wells producing from the Montney Formation. So we're looking at over 7,000 wells here. So I need to actually reduce it down to a more representative group to continue on with my process. So what I started off doing is I actually created some queries for the production years, and then I was able to create bubble maps illustrating those. So here we can see all the wells that came on prior to 1960, in the 60s, 70s, 80s, in the 90s, and so on. So you can see in the 90s there's exploration into new areas, some infill drilling, 2003, 2006, 2009, 2009 to 2012. You can definitely see a lot more activity, and then everything since 2012, represented by that turquoise color, definitely a lot more wells. So when looking for my representative group, I want to look at the area where we've seen a lot of recent activity, because this is going to show the recent technologies that are being used. So when I want to take the data from AccuMap into Harmony, I want to focus on only the wells that have been drilled since 2012. And if I do that, that's reduced it down to about 2,000 wells. That's still quite a large group. So then I spatially grabbed an area over here where I figured there was the most amount of recent activity. So the wells that are represented by red, that's about 1,600 wells that have been drilled since 2012 in that area of high activity. So I exported the data out of AccuMap and brought that data into IHS Harmony. So IHS Harmony is a reservoir engineering tool that has different analysis methods within it. So things like decline analysis, type well, type curves, analytical and numerical models, just to name a few, are all within IHS Harmony. So in order to find, I have 1,600 wells in this project, so in order to again reduce this down to a more representative group, I was able to get information from the well completion frac database that has a lot more information on the completion technologies, types, and that kind of thing that I can bring into Harmony to help determine which is more representative of this area. So this has things such as, there's my well's name, the number of stages, the total proppant being used, lateral lengths, and even the technology group. So I can bring this information into Harmony, and definitely one of the nice things is it'll actually match up the wells in that Excel spreadsheet that I brought from the well completion frac database with the wells that are already in Harmony. So it kind of takes the user error portion out of this and does the matching for you. So if we take a look in the Attributes tab, you can see that I've brought in the information for all 1,600 wells in this project. So to visually show you what's going on, I actually created bubble maps representative of some of those attributes I brought in. So I created a bubble map representative of the technology group. So you can kind of see the blue is standing out a little bit more, which is showing that the plug-and-perf ball method is the most common in these 1,600 wells. I did the same thing with the number of stages, and in this case you can see that the red is standing out a bit more. So that's showing that around 9 to 15 stages is the most common in this area. I did the same thing with the amount of proppant, and that showed me that about 175 to 200 tons of proppant per stage was the most common. So I have 1,600 wells in this project, but I want to reduce it down to those certain criteria. So in the attributes, I can actually create a query that's going to find all the wells whose proppant is between 175 and 200, number of stages between 9 and 15, and the technology group of plug and perf ball. And we've also already reduced it down to showing only the wells that have been produced since, or drilled since 2012. So I can query this entire project of 1,600 wells and find that 63 wells match that criteria. So these are the wells that are representative of, or that I want to use as my representative group. So now what I can do is I basically just brought those 63 wells into an identical Harmony project just to keep it simpler here. But now I have my 63 wells. The next step is to generate a type well of all 63 wells. So if I launch this group, what I've created is a rate cum type well of all those wells. So what I need to find is this a representative group? That's the question I need to ask. And if I look at this, well, I'd expect to see a similar shape for the wells if they're being operated under constant conditions, but I'm actually seeing 3 different trends. So I did go through and analyze each of these, or take a look at each of these wells, and I broke them out into 3 different groups. So the first group that I found was a group that only seemed to be producing at a constant rate. There was no decline that I was expecting to see. They all were constant rate like this. The next group I saw, I called this one the linear declines. There was a decline, but it did seem to be a very linear trend. So they all had that type of production trend to it. And then the final group that I looked at, which I called normal decline, those ones actually showed that high degree of curvature, that decline that I was expecting to see for this. I mean, these are horizontal multifrac wells, so you would expect to see that B value of 2 because they're in linear flow, which is exactly what I'm seeing in this group of wells. So then I'm wondering, well, if I'm able to split these wells up into 3 distinct groups, maybe that representative group that I found is not actually a representative group. So I was wondering maybe spatially I had found, maybe spatially there was a reason why I was able to split these into different groups. So I created some flag layers to show where the constant rate wells were, the linear decline wells were, and then also the normal declining wells. And basically spatially it shows that they're all over the place, so there is no trend spatially. I did the exact same thing at looking at which operators were producing these wells, and there was no trend there again. So what I've decided is that the reason that I'm able to split these wells into 3 different groups is because they're being operated differently. Some of these wells are being throttled and then slowly being released, and that's why we're not seeing that expected trend. So keeping that in mind, I then went into my normal decline analysis and I tried to capture the shape of the decline. So I put a decline on here, a b-value of 2, an effective decline rate of 74%, and I feel that this trend fairly accurately captures of most of the wells in this group. Now, understanding that a b-value of 2 will not continue on forever, I also made this into a modified hyperbolic, transitioning at that 7% effective decline rate. But this decline trend does tend to match onto all of these analyses. So then I took this decline analysis and brought it over to the other group, that linear decline group. And for the first period of these wells, they're changing their operation, but eventually they will go on some form of constant back pressure conditions, maybe once the surface reaches their line pressures. So applying it to this data set, later in the life they do seem to fall onto that decline trend. Early in the life not so much, but later on I can see them falling onto that decline trend. So then I did the same thing with the constant rate group. And, well, this one doesn't work quite so well. These wells are still being operated under constant rate, so they eventually will come to this, but in the meantime they are all constant rate and not really matching onto this decline trend. So as we're going through this, we do need to understand that this is an empirical technique. We're extrapolating out into the future, and we're assuming that this trend will persist. From experience, we know that these b-values will decrease and it won't remain at such a high b-value. But basically, decline analysis is empirical. So what I decided to do is I wanted to see if I could support these decline trends using more scientific methods. So I was lucky enough to actually have daily rates and pressures for one of my wells, and also had the PVT information for it. So I was able to do rate transient analysis on one of my wells. So what I did is I created a numerical model, and let me just create this. And so the numerical model that I've generated, it considers the reservoir parameters and the completion information, so things like your pressures, the permeability, the number of fractures, and comes up with a forecast for this. So I created this model here, and I do think I have a pretty decent match on my data, and from there I'm able to pull the reservoir parameters from this model match and create a synthetic test case. So what I did in the synthetic test case is I input a synthetic pressure profile for the wells and generated some rate forecasts. I did keep the fracture completions consistent among them, and then what I did is I ran probabilistics on them. So I essentially ran thousands of analytical models from that test case, but it was able to use different distributions on certain parameters. So things like my number of fractures, my permeability, my fracture half-lengths, different distributions on those, and that was able to generate out a range of forecasts from that probabilistic analysis. So the results of these are right here. So these are the decline analyses, the P10, P50, and P90 results of the probabilistics. So if these are the more scientifically generated results, what I then did is I went and I actually matched a multi-segment modified hyperbolic decline to that probabilistic analysis. So I did find, I also added in just a traditional modified hyperbolic, which is the one in purple, and I did find that that was slightly too optimistic, whereas the multi-segment modified hyperbolic in the red data there matches up very nicely with the probabilistic results shown in blue. So really using just a traditional ARPS decline was too optimistic, but by constraining it with that numerical model and matching a multi-segment decline to that forecast, I was able to come up with a more scientifically generated result. Now, to make it easier to import this data into Entero Mosaic and run economics on it, what I did is I just duplicated these decline analyses into another well shown here. So these are your P90, P50, and P10 decline forecasts from generated technically from your numerical model, but matched up with a multi-segment decline analysis. So I have now going to take this into Entero Mosaic, and Entero Mosaic, it's a petroleum economic evaluation tool, and what it can do is it can open up a Harmony project and then select which forecasts you want to pull in. So it is pretty easy to update any forecasts, and you can see there's the button right in Entero Mosaic to import the Harmony forecast. Now, coming soon, November 2015, IHS Harmony is actually going to have improved exporting abilities. So we're going to export out common decline parameters into Excel, and we're actually going to have templates for the desired format to Mosaic. And then later in December of 2015, Entero Mosaic will have improved importing abilities. And so they'll be able to pull multiple wells and analyses at a time. So we're both working to improve the connection between the softwares, to improve the workflow for this asset valuation technique. So to begin the economic evaluation in Entero, we need to input the capital costs. So we did keep the capital costs consistent between the P10, P50, and P90 forecasts. So the capital costs, they do kick in when the drilling program begins, and they are just generic costs. We also input the operating costs, so monthly operating costs. The variable costs are based on the volume of production, and we do have abandonment costs scheduled at 36 months after the well goes offline. Then for the price forecasts, all the different consulting firms publish their price forecasts. We use the IHS Reservoir Engineering Consulting Services gas price forecasts, and then also used a default escalation of 2% on those forecasts. As for a drilling schedule, we came up with a simple 3-phase program. The first phase was 5 wells, and that basically allows us to do some analysis after those wells have been drilled to ensure that we're on the correct path, to modify any of the drilling or completion of the later phases if needed. Now, we also put in a gas facility constraint of 150,000 MCF per day. So once all this has been input, it generates out the production chart. So this is the aggregate production rate versus time chart based on the drilling schedule and includes the individual well rate forecasts. And then at the very top with that red dashed line, you can see the facility constraint. So if we look at the individual production charts for your P10, 50, 90, again, based on your 3-phase drilling program, you can see that the P10 definitely our optimistic case. It does hit that production limit. Our P50, it also hits the production limit but comes down much sooner. And then our P90, which is our low case, never actually reaches that production limit. So from those production charts and the other inputs, we're able to determine some economic indicators. So many different economic indicators are calculated here. We also used a discount rate of 10%, but you can see things like your discounted payout, your NPV per BOE, NPV per discounted investment, but all of these are actually indicating that this is quite a viable project. Now we took it a step further and we're actually able to do a Swanson mean on this, which is just a calculation of mean based on your P10, P50, P90 with different weightings on those percentiles. But if you look at it, we're looking at about 2.25 years to recoup our investments. So this is definitely a very viable project. So to review, we used IHS AccuMap to query the data. We generated bubble maps to show the evolution of the field, and we identified an area of representative wells for analysis. We then used IHS Harmony in conjunction with the well completion frac database to further filter the data. We used type well and modeling, all to generate out rate forecasts. We took those rate forecasts into Entero Mosaic, and along with project costs, drilling schedules, and price forecasts, we were able to determine the economic viability of the asset on which to base our future decisions. So this asset valuation was completed fairly quickly, and you're able to take this down to whatever level of refinement you require, whether you simply do a type well or you do have the ability to go down and do rate transient analysis. You can science this as deeply as you want. But really, I was just hoping to show you the value and viability of this process. Thank you very much.